Hi, Assalamualaikum. In this video, we will discuss integration. Okay, this is from your lecture note, okay, dalam buku yang kita guna masa kuliah. We recall back from page 118 under chapter 2, integration of trigonometric function, inverse trigo function, and hyperbolic function, and also integration of inverse hyperbolic function. Okay, dalam kelas kita dah discuss nombor yang ni, okay, number 2 Roman, and then number 3, number 6 Roman 1, and then number 8, number 9, number 10, number 12, number 13 1 Roman and 2 Roman. Okay, semua yang kita dah discuss ni ialah bila kita integrate, kita akan dapat either inverse trigo function or inverse hyperbolic function. Okay. So, dalam video ni kita nak discuss nombor soalan yang kita belum sempat discuss masa kelas ya. Iaitu number 1, number 2 Roman 1, and then number 4, question number 5, question number 6 Roman 2, and then question number 7, and question number 11. Okay, ini from your book dalam page 118 under chapter 2. Okay. Okay, you refer from your lecture notes page 118 buku ni ya. Okay. So kita tengok question number 1 under integration. Integrate x cos 10x squared dx. So how to evaluate this integral? Okay, first every time when we have hyperbolic function here, okay, kita compare dengan appendix. Okay, kita tengok appendix yang diberikan masa final exam. We have formula for integration of cos ax dx. So kita ada formula untuk cos, untuk integrate cos. So bila ada formula dalam appendix, okay, so kita akan guna u substitution, and u yang kita pilih adalah dia punya argument ni, okay, 10x squared, kita punya u. Okay, so to integrate this question, okay, we can use integration by u substitution. Okay, our u equals to 10x squared. Okay, every time after we identify u, we should find du over dx. Okay, kita differentiate ni, so we have 20x, and then we write dx as a subject. So we got du over 20x. Okay, we just cross multiply. Then we substitute back into the given question. Okay, so kita ganti, we have integration sign, and then x, and then cos. 10x squared we let as u, and then we replace dx equals to du over 20x. Okay, and then we can simplify x here and x in denominator here, and at the same time you can move out constant 20 here. Okay, so we got this. Okay, after we move out constant 20 over 20 here, so we got 1 over 20, and then integration of cos u du. Okay, sebab kita dah simplify x here dengan x in denominator here. Okay, and then from appendix, if we have integration of, let's say we replace a equals to 1, so we have integration of cos x dx equals to 1 over 1, which is 1, and then sinh 1x. Okay, kalau kita replace a equals to 1, means that if we integrate cos u du. So we got sin u. Okay. So we have 1 over 20 after we integrate cos u du from this formula, we got sin u and then plus c because this is indefinite integral. And then we replace u equals to 10 x squared. Okay, so this is the final answer. After we integrate this, we got 1 over 20 sin 10 x squared plus c. Alright. Okay, masih lagi kita refer buku yang sama under page 118. Question number 2, Roman 1. Integrate square root of tan to x sec squared to x dx. Okay, first macam mana kita nak evaluate integration yang ni? Okay, mula-mula kita refer daripada appendix. Okay, so from appendix, okay, kalau kita compare one by one, there is no formula involving square root of tan and then combine with sec squared. Okay, there is no formulas. Okay, yang ada adalah sec dengan tan, lepas tu dia tak ada square root and then dia tak ada kuasa 2 ya, untuk sec. So tak ada formula untuk integrate soalan bentuk macam ni kalau kita compare straightforward daripada appendix. Okay, so means that our u not equals to the argument. Maksudnya kita tak boleh buat u equals to 2x sebab kita tak ada formula untuk integrate function sec tan dengan sec squared kita ada kat sini. Okay, kita still lagi guna u substitution. Okay, tapi kita punya u kita adalah function yang dalam sec, yang dalam square root ni. U kita adalah tan to x. Okay, ini kita punya u. Kenapa? Sebab bila kita differentiate tan to x, kita akan dapat sec squared to x. Nanti kita boleh potong dengan function yang kat sini. Okay, so every time when we use u substitution, after we identify u, we need to find du over dx. Okay, kita differentiate tan to x. Mula-mula dapat sec squared to x, lepas tu differentiate pula to x, so dapat 2. Hubungan kat sini darab. And then kita write dx as a subject, we just cross multiply. So we have du over 2, letak 2 kat depan. And then sec squared to x. Alright. And then we rewrite this question in terms of u and du. Okay. Okay, so kita tulis macam ni, equals to integration of, we still have square root, and then tan to x equals to u, and then sec squared to x, and then times dx. dx kita equals to du over 2 sec squared to x. Right? And then we can simplify sec squared to x here, okay, and at the same time we can move out constant over 2 from integration sign. So we can write like this. Okay, we have half and then integration of sec u du. Okay, half ni datang daripada over 2 ni. Okay, kita move out. And then to integrate sec u du, first we need to write sec u equals to u to the power of half. Okay. And then since dia punya power ni not equals to -1, so we can integrate using power rule. Okay. Power rule for integration tu means kita kena tambahkan satu kuasa, lepas tu perbalik. Okay. So we got this. We still have half in front and then times u to the power of 3 over 2. Mana datang 3 over 2 ni? Half plus 1. Okay. Lepas tu perbalik dengan kuasa yang dah tambah tadi. Okay. per 3 over 2 and then plus c because this is indefinite integral. Okay. And then over 3 over 2 ni, we can write multiply by, kita terbalikkan, okay? Kita exchange 2 and 3 here, so we got times 2 over 3. And then u to the power of 3 over 2 plus c, lepas tu kita boleh simplify 2 from numerator here and 2 in denominator here, okay? Then we got 1 over 3 u to the power of 3 over 2 plus c. And then last kali kita replace u equals to tangent to x. Okay. So the final answer equals to 1 over 3 and then we replace u equals to tangent to x and then bracket to the power of 3 over 2 and then plus c. Okay. This is the final answer after we integrate this. Right? Thank you.